All right. So, good evening, everyone. So I hope that all of you are doing great. Uh, Today we'll be working on the new chapters. So, again, the notes and yes, good evening, clear. And the notes and the lecture video is basically on Blackboard. If you have been working on it. Um, Yes, so I hope that everything is clear. So we basically learn how to compute is the mean and the standard deviation. So that was the chapter that we worked through. Okay. Um, yes, it was chapter. So we haven't finished chapter 4. We still have a lot to learn. We need to know about the final summary. And then after that, we have to, jump to chapter 6. So chapter 5 and 13 is a single chapter. So it's basically connected. We going to learn them at the end of semester when we trying to do with the correlation. All right, okay, it's actually great to hear that. And um, concerning the homework for most of you who still working on it, and you know the fact that for those of you who have the grades, finish the homework within 2 weeks trial, so you should have received your grade that I emailed you. If you don't see your grade, just let me know at the end of class. So I'll be more than happy to let you know what it is. So now we're going to work through chapter 4, and then we're going to start the hardest chapter of the entire semester. So that is on chapter 6. Okay, so I kid you not, this is one of the hardest chapter that we ever had, because that's basically working. We have to work through the probability concept. But before we jump to chapter 6, so I just want to let us know that we're going to have the third exams right after we finish chapter 7. Okay, so so we know about the standard deviation. So now we're going to learn how to figure out the final summary. So this is going to be the next chapter that we have to work through. Okay. So I actually uploaded chapter 6. So remember that there is no chapter 5 until the end of semester. Okay, so just don't worry about that. And there's no calculation involving chapter 5 either. So there's nothing that you have to worry about. So now, I'm so sorry, but I gotta mute because there are some noises going on. I apologize for that. So if you want to ask questions, make sure that you are unmuting yourself. Okay. Okay, I'm sorry with that. So now we're going to deal with the next part of the chapter. So this is what we have for the box plot. So what does that mean? So we're going to the new chapter. So that the new part of the chapter 4. So this is what we call a final summary. Okay. I apologize for my dog. It's barking as well, so it's not very convenient. So this is going to be the things that we're going to deal with for today, and hopefully that we're going to talk. We're going to spend time work for chapter 6. So this is what we call a final summary and identify the outliers. Okay. All right. So after we have learned about the average, so the average is something that we call the central values for to neutralize all the data values. But all right, so I have some noises, so I got to mute. I apologize for that. And today we're going to work through the medians. Okay, so the medians will also be called as the central tendency of the data set. Okay, data, but this will be involving the position, not about the weight or the data set values. I mean, it does depends on the data set value, but the most important thing is that the median involving the central tendency of the data. okay, involving a position, okay? And so this is going to be dealing with the percentile. So the percentile is going to be a big deal. So what does that mean by the percentiles? The percentile is basically means that each data set going to occupy the same amount of percentage of the data set. Okay, so the entire data will be divided into 100%. Okay, and so let's say we have 10 data sets. So each data going to occupy around 10%, okay, of the tile. All right. So the median is basically going is basically splitting up the data into 50 and 50. Okay, so that's going to be like a big part of the data set. So the medians will also be called as the Q2 of the data set. Okay, we call this one's Q2. All right, and how are we gonna draw the data set? So we're going to split them up into 100%, okay, 100 percentile. And we have to arrange them from the smallest to the biggest, okay? So arrange it from the smallest data and to the biggest data set values. Okay, so this always be the case that we have to deal with this. If we don't arrange on the exam, so there actually a question like that on the exam, the third exam. So if we forgot to arrange it, there will be a big portion of points will be taken away on the exam. So we got to be careful with this. The Q2 going to be called the medians, and it's going to split up the data set into half and half. So I'm going to draw the middle points here. So we call this one a median, or the Q2. Okay, and then we're going to have to find another median for that. So what is another median? So this we call the Q1. Okay, so what does Q1 stand for? The Q1 is basically the first quartile. Okay. And so what is used for? It's going to split 25% and 25 percentile from the smallest up to Q2. Okay, so that'd be the medians between from the smallest numbers up to Q2. So we just have a certain concept like that, and then we go into apply, you know, for a certain example, and then we should be able to deal with them through the Q2. Right, and so let me just change the marker real quick for that. Okay, so now we're going to figure out another Q and another quartile. So this one we call Q3. Okay, so what does Q3 represent? It's going to be the third quartiles. Okay. This will be the median from the Q2 and to the biggest. So the final summary, we need to find 3 medians, and that's technically going to help us solve a problem. And the last 2 numbers will be the smallest and the biggest. So we have 5 different numbers. So this is why we call final summary. Okay. What is the first? When is the third exam, or what is the third exam? So the third exam should be covered from chapter, I would say from chapter 3, 4, 6, 7, but the material will be taught for chapter 4 to chapter 7. Right after we finish, the chapter 7 material, so we're definitely going to have the third exam. It should be like 3 weeks from today, I believe, and that's the thing that it put it on a schedule. Okay. Yeah, October 6th. If the October 6th was a little too early, it should be 2 or 3 weeks from today. Yeah, so let me just double check the schedule. So 1, 2, yeah, it should be around that. Okay. All right, so the whole point is that we need to look for 3 medians. So the way that we can figure out medians is generally very straightforward. Okay, so let me just rewrite them. The entire data set will be 100 percentile. It's different from percentage because percentage going to set of the equal weights for each percent of the data values, but the percentile is different. Okay, so let's say we have 10 data, regardless of the value that we have. So each data going to be 10%. Okay, so let's say the first number is 1, and then the second number is 5, and then the third number is 10. So even if the difference is going to be a lot different, but they still occupy the same percentile. So that's the meaning of it. Okay, so let me just repeat that again. So final summary, usually done by looking for those 5 numbers. So the first, we need to figure out the smallest, and then the biggest, right? So this one is done after we arrange the data set in order. Okay, and after that, we're going to find the Q1, Q2, and Q3. Okay, so those 3 medians will be the thing that will grade on the exam. Okay, so, and if you ask me what is the application for that, so when you read the chapter summary, you can literally check the box plot. So this is how we going to see them. So this is the smallest, this is the biggest, and then we have Q1, Q2, and Q3 given by the box plot. So we're going to know whether the curve is positively skewed or negatively skewed based upon the stat crunch. So this is what we have for the final summary. If you ask me one of the applications, I'm going to tell you when we have like a stock candlestick. So this is one of the most important application that you might have seen in the stock market. So where you might have a certain curve, and then you want to know whether the stock's going to be at the low point, the highest, and the opening close, and how it's going to travel around, whether it should down or should up or left. So we can, of course, this is different modelings for the potential directions and so on and so forth. Okay, but we're definitely not going to be interested too much in a certain thing like this. We want to utilize the final summary to figure out the outliers. So I will let you know what it is. Okay. So before we can start a final summary, we're going to go through a few examples, right, to figure out the medians or Q1 and Q3 respectively. If there are 2 middle numbers, so let me just figure out that the medians will be the middle numbers of the data. Okay, so we should know this one for sure. If there are 2 middle numbers, okay, so this is just the assumption that we might have on the exam. If there are 2 middle numbers, what should we do? If there are 2 middle numbers, so we can't really take any of them, right? So if there are 2 middle numbers, we're going to average out these 2, and so this is how we're going to set up and figure out the medians, okay? Yes, and then we divide it by 2. Right. So if there are 2 middle numbers, then the medians would be equal to the sum, the average of these 2. Okay. So it seems hard, but when it comes to like a certain problem and a certain example, you definitely gonna see that the whole picture right away. The only concern that you might have is how we're gonna split up the data sets when we find the Q1 and Q3 respectively. So the Q2 will be the thing that we have to solve first. Okay, so let's take one example and see what's going on. Example 1. So we're going to have the following data sets, right? We can have 1, we can have like 4, we can have like 11, we can have like 7, we can have like 15, we can have like 8, right? and we can have like 26, for instance, okay? Or maybe not 26, maybe 45, doesn't matter, okay? And now the first thing that we have to do with if the questions ask us to look for the final number summary, what is the first step that we have to solve? We need to arrange the data set in orders, right? So the question usually find the final number summary. The first thing that we have to do is to make sure that they are in order. So when you put them in orders, let me just change marker real quick. So we have 1, 4, 7, 11. No, I'm sorry, I'm missing 8. I apologize. And 11, and we have 15, and we have 45, right? So if you ask me why I pick 7 numbers, why not 6? Why not 10? I have my own reason for that. So we're going to have n equal to 7. So the n will be the number of sample size that we have. Since we have 7 data set, I call n equal to 7. Okay, so why I pick 7? I have my own reason for it. Because 7 is my lucky number. I love number 7 so much, and it also because it's always been my lucky number for that. And one other reason is when we have 7 data, it's will become very easy to look for Q1, Q2, and Q3. I'm going to show you. We don't have to do any calculation for that example. Why? So the first step, we need to divide the data set in order. We finish it. And now I need to look for the, so this one is smallest, right? So this one is biggest. So we don't have to do that on the exams. You don't have to show this is smallest, this is the biggest. I already know what it is, right? So now we have to look for Q2. So apparently the Q2 is the median of the entire data set. So we're gonna split up the data into half and half, right? And the Q2 for that example is 8. Are we good? So we don't do any calculation. It's directly just middle numbers, only a single middle number, so we good to go. So remember, if A is the middle numbers, then we're going to plot this out. We're not going to take it when we evaluate a Q1 and Q2. So there's no way I can take A for Q1 or A for Q3. That will be biased, because if you go for Q1, so the Q1 to look for Q1, so meaning that we're going to have the first 4 and then the last 3 for Q3. That is not fair. If this one go for Q3, it's not fair for Q1 either. So the only thing that we can do is that if the Q2 is one of the data set values, we're going to get rid of it. Okay, and then we're going to look for Q1 using the first 3 numbers. Okay, so we don't count 8. Remember that, we don't count 8. So given by 1, 4, and 7, and we can also figure out the Q1s based upon that. So the Q1 in this case will be equal to 4. Okay, and on the other hand, so we're going to have to look for Q3. So we also take 3 numbers.
I have a question. If we have 2 middle numbers, do we count that?
Yes, we do. So if we have 2 middle numbers, then one's going to go for Q1 and one's going to go for Q3.
Okay, thank you.
You're very welcome. So that is a good question for that. If we have 2, it's fair. So one's going to go for that direction, the other one go for another directions when we look for Q1 and Q3 respectively. So for that part of the question, so we can figure out, we can figure out Q3 without doing any calculation for that. So this is done, okay? Are we good? Any question? Any concern for that? So the final summary that we have, if you want to write them down, just in case that you want to put it down, I do not ask you to do so on the example. Some people might put like smallest will be 1, and then Q1 is 4, Q2 is 8, Q3 is 15, and then the largest number is 45. So I feel like it's fair enough to have all of this set up, but it's not necessarily, because I know what it is when I look at the question like that. So let me just change the marker real quick, okay? All right. So now we're going to go for another example and see what's going on. So remember the first step, that don't forget to arrange data set order. Okay, it's very crucial step for this. All right, so now we're going to have another example. Okay, but instead of giving us 7 data, so now I only give you like maybe I will give you like 8 or 10 data sets. Okay, so we have 10 data, so that should be straightforward. So let me just do that. 17, 4, and then 15, and then 25, and then 36, and then 19, and then 40, and then 33. Let's say I do like 10 data sets, just want to make sure that we know what it is. And then we're going to have like 60, and then 120, right, for instance. So we have 10 data, okay? So the things, if we have more data, it's going to take a little time to arrange them in order, right? So that's going to be a little big deal. So, but we have an even data sets, right? So we're definitely going to have a 2 middle numbers when we look for Q2. So the first step that we have to do, again, that we need to arrange them in order. I'm going to put the first one is 4, and second one is 15, 25, 36. I'm sorry, missing 19 is right there. I apologize for that. Okay, and then I think I'm missing 17 as well. And then we have 40, and we sorry, we're missing 33. Yeah, so when we have like more number, it's just a little bit more work. And then we're going to have to 60 and 120. Okay. Yeah. All right. So now we have 2 middle numbers because we have 10 data. So we're going to look at the 5th and then the 6th one. Correct. Since there are 2 middle numbers, we need to add them up and divide it by 2. Correct. So this is how we're going to look for Q2. So let's take 25 plus 33 over 2. All right. And so why do we have to divide it by 2? Because we have 2 middle numbers, and then we're going to do that on a calculator. So 25 plus 33 over 2. And the answers that we have is nothing. We have 29 right there, okay? So that's will be the medians for the data sets. So now I want to look for Q1 and Q3 respectively, okay? So since we have 2 middle numbers, meaning that one's going to be going for Q1s and one's going for Q3. So the Q1 that we have to look for the value between 4 to 25. So apparently 17 is going to be the Q1. And 40 is going to be the Q3, correct? Any question? Any concern for that? Okay, that makes sense. If we have 8 data, so I don't like number 8 because let's say we have 8 data sets, right? So we have to do like 3 calculations. You have to add up 2 and divide it by 2, and then we're going to count 4 and 4 each to look for Q1, Q3. So we have to do another 2 calculations for Q1 and Q3. It's gonna take more time. But for 10 data, so we only do 1 single calculation, and then just leave the other ones easier. Okay. But the only point, but the thing is, so we not only we do not only want to figure out a final summary to check whether or not it's going to be the positive school or negative school. So the positive school is going to look like this, okay? So positive school, meaning that the median's going towards to the left, okay? So let me just show you what it is. Just copy and paste real quick for that. Okay, so this is what it looks like. I mean, understanding the shape is pretty important because we want to see how the data set trends go. Okay, so the positive skew is, so the Q2 will be right there. Okay, so this is what we have for Q2. It's going toward to the left side. What does that mean by going toward to the left side? Meaning that there will be more data set focused on the left. Okay, there are more data set focused on the left. So this is what we have for positive skew. Okay, so this means that, so this is the median around this, or Q2. Okay. Any question? So the average or the mean, so I'm gonna draw it. So the mean should be, remember the mean is, it doesn't really care like how many data. I'm going to neutralize all of them. So whatever the value that we take, I'm going to add them up and divide it by the number of data set values, right? So so if we have like a big data set, but with a fewer big data sets on the right, but it still generated relatively big average or the mean. So meaning that we have this mean basically bigger than the medians, there'll be more data set going toward to the left side. Okay. Similarly, if the Q2, I mean the median is going toward to the right, so what the shape looks like? The shape should be going toward to the right, right? So this is what we have right there. So I'm not actually in a good shape drawing some pictures like this. Okay, so let me just redraw them. So I apologize. I'm not very used to a new mouse. I just got one here. So this is what we have for the Q2. Okay.
I think they're editing it right now. So
That's so weird.
we refresh.
Okay, so I'm sorry about that. And so this is what we have for Q2. All right, so yeah, so this is what it looks like. So the negative skew, meaning that the median's going to be able to beat the average. Okay, so it's going toward to a negative direction. So there'll be more data, there'll be more bigger data sets. The positive direction, meaning that the median is actually smaller than the mean, there'll be more data set going toward to the left, and its direction is going to the positive direction. Okay, so this is what it means by the final summary. Any question? Any concern? Any question for that? Okay. On the other hand, so we're going to utilize the medians the Q1 and Q3 to look for the outliers. So what is so important to have the outliers? For instance, we have 40 members in this class, and then 3 of them got a diarrhea before the exam, so they couldn't make it. So what happening for that? It would take their grade to compute the average for the entire class. So it's basically a little bit off the tangent because they do not have a chance to take the exam, right? So when I look at the average, it should get lower before I remove them and compute a new average for sure, right? So all of these data sets going to be called the outlier because basically off the tangents, they have some exam excuses, and then they should not be counted when we take the sample or run a survey for that. So it's very important that we have to treat the data with a very careful consideration. Okay, so if the data set turns out to be relatively good values, so I would call them the good value. So it's really good to run the report or to run the analysis. But if there are some bad data, we'll call them the bad outliers, the outliers. So it might basically prevent you from getting, accurate result or the precise analysis that you aim for. Okay, so what's going on for this is we need to identify the outliers. It doesn't necessarily mean that we might want to remove them. It's just something that we have to be paying attention to it. We need to treat them carefully when you run the analysis for that and identify the outliers. So the outliers will be called the out of the tangent of the data sets. Okay, so how can we do that? The first that we need to figure out the IQR. Okay, so the IQR will be called the interquartile range. Okay. It can be computed by Q3 minus Q1 from that. So what is the interquartile range? It will be the range between, so we're starting from that one. So hold on a second, let me just do that. So this is Q2. We don't really care much about Q2. Okay, so we're going to use the Q1s right there. Okay, and Q3. All right, so so this is the Q1 and this is the Q3. So the interquartile range is basically the range between there'll be a difference between the Q1 and Q3 right there. It's going to occupy like 50% middle of the data sets. Okay. All right, so because you're going to have, we're going to take a 25 from Q1 up to Q2, and then 25 come from Q2 up to Q3. So that will be the most dense data set range, and it's going to most likely representing all of the data set values from Q1 and Q3. Okay, if the curve is symmetric. So now using the IQR, I can identify the lower fence. So we need to set up the fence. So why it's so important to set up the fence? Because if the fence will be called the standard, okay, the standard treatment for any value that's going off the fence, they will be called the outliers. Okay, so the fence can be set up by taking the Q1 minus 1.5 times the IQR. Okay, so the Q1 is basically given, and we know what it is. And 1.5, so a lot of you will be asking me why it's 1.5, because, but why not 1? Why not subtracting the IQR? Because I want to make sure that the data set is bad enough that we can beat the 1.5 times. So this one will be around 50%. We multiply with 1.5, and then we're going to have around 75%. Right, and compared to the Q1, so if the Q1 is just only have from smallest up to Q1 is 25 percentile. If this 25 percentile was able to beat the 75% of the middle chunk, so they will consider a really bad outliers. Okay, so the same thing for the upper fence. Okay, so we're going to do the same setup. So we're going to take the Q3s, and then we minus 1.5 times the IQR as well. Okay. Oh. All right. Any concern for that? How does static group going so far? So this is how we're going to set up the fence and work through it. Okay, so so the fence is going to be established on the boundary of the data sets. Okay, so if any data that is smaller than the lower fence or bigger than the upper fence, so that will be usually kicked out of the sample. Yeah. yes, this is the way, and I think this is the only way that we can determine the major outliers. The outliers shouldn't be like too many data sets unless they are basically occupying like a big force uh, of of the data sets. Okay, but generally it should be like one or two, given now only 10 data sets. Okay, so but if you have like a million data set, you might be able to identify more and more outliers. But since we don't really have the tools to do it, and so we only just play around with a small example. Okay. Okay. Same thing to the market, to the stock, when something that travel in the same moment, and all of a sudden the price is jumping up and then go all the way back down in a few minutes, and this price will be considered the outlier. It's just a certain thing that is going up like this. So the forces, the shorts, whatever cover, and so on and so forth. And but we definitely not going to have enough times to use the application for that as well. But we're going to solve that equation with few examples that we just done earlier. So let's check out with the question that we have done right there. So I'm going to take that example. I'm not going to redo them. So let me just take that example. Okay. And then I'm going to identify the outlier using that example, right? And I'm pretty sure, I'm not like 100% sure for that, but so we can see that the number jumping from 1 to 4, so only 3 difference, and from 4 to 7, from 7 to 9, I'm sorry, from 7 to 8, and then jump from 8 to 11 and 11 to 15. But all of a sudden, from 15 is jumped to 45. So I do expect that 45 will be the outliers. Based upon the the intuitive assumption that we just made. Okay, so that's very important to understand what it is. But on the exam, you can't just say something like that. So the jump is predictable except for 45, right? So we can just say 45 is outlier, but you can't literally just answer the question like that on the exam. So you have to show work and then prove that 45 is the outliers. Okay, so given by that example, I'm going to compute the IQR. So since I have the Q1 and Q3, I just simply take Q3 minus Q1. Okay, so this going to represent the 50 percentile in the middle of the charts. So the Q3 that we have is 15 and minus 4. So this we got this one equal to 11. Any question? Minus 4, sorry. Okay, so this length is very important for that, right? And then now we're going to set up the fence. Okay, the fence going to help us determine the outliers. So the lower fence in this case will be Q1 minus, so we need to make sure that if the fan is cool enough, but there is still some stubborn data. So the fence, so how can we set up the fence? We're going to take like Q1 and then we subtract. So we have to subtract. So you're going to make the fence going all the way to the left, right? Times IQR. Okay. So this is how we're going to set up the fence here. All right. And so let's say the fence should be around here. Just one example. Okay. And then we're going to take plus 1.5 times IQR. So Q3 we've add, so you're gonna make this longer. 0.5 times the IQR, right? And this is going to give me the fan setup right there. Okay, just like that. But all of a sudden, I can find some data set that can actually go here, right? It's jump to here or maybe jump to there. Maybe one of that data just go out of the tangents, just go out of the boundaries, and they will be called the outlier. Okay, so this is the thing that we have here. Okay, So let's take one example for that. So let me just finish this real quick. So I'm going to take the Q1 minus the IQR, so minus 1.5 times the IQR. Okay, so the Q1 is 4 and minus 1.5 times 11. Okay, so we can do that. These calculations, of course, are not here, so we can just use the calculator for that. So we can just take 1.5 minus 4 minus 1.5 times 11. So we have the answer is negative 12.5. Okay. Are we good? Oh, for some reason. And then I'm going to set up the upper fence. So why is so important to have the upper fence? So we want to see if there are any data set that is bigger than that. But apparently on the lower fence, there's no data set that is smaller than negative 12.5, right? Because the smallest number is 1. So 1 is the safe value because, you know, it's basically not going off the tangent. It's not going out of the boundaries of negative 12.5. So we good to go. Okay. For the upper fence, so we're going to take Q3 plus 1.5 times IQR. So for that, we're going to get it done right there. So we're going to take, hold on a second. We're going to take the Q3 equal to 15 plus 1.5 times the IQR is 11, one more times. And we want to compute this calculation. So we definitely want to do it on the Google. Okay. So I got the answer is 31.5. Any concern? So what's happening for this is, so the lower fence, so the fence that we set up will be between negative 12.5 and 31.5. Can you find me any values that is smaller than negative 12.5 or bigger than 31.5? So the answer is yes, right? Because we have one single value. So we have 45. 45 is just locating as of the boundaries, right? So the 45 is bigger than 31.5. So I called 45 as the outliers. Does it make sense? Okay. So 45 is the outliers.
We have to find a value less than negative 12.5 and greater than 31.5.
Yes, but definitely one is safe because one is not going off the tangent. So you can see that the one is the jumping. So if we go like from 1 and then the next value was 64, for instance, so one definitely the outlier because the difference was so big compared to like a few values later on. So the whole point of setting up the IQR, we need to take that 50% of the middle chunk of the data set. So this middle chunk is very important because that's going to be the representation of the entire data set values. And then we're going to take that and then we multiply by 1.5 to make it even bigger to 75%. And then we subtract from Q1. So you remember from the smallest of the Q1, that's going to hold up to 25% of the tile. So what's going on if this 25% still be able to beat that 55%, I'm sorry, 75%, that's definitely going to be the outlier. Same thing for Q3 plus 1.5 times IQR. So apparently the 45 was able to beat that 1.5 times the IQR starting from Q3, and that point will be called the outlier. Okay. I feel like that's fair enough for that example, right? So should we go one more example? Are we good to go? good to go. I think we can do one more here, but I suspect that the Q1 the Q3 was 40 and Q1 is 17. 40 minus 17 is 23 times 1.5. And then add 40. I suspect that 120 will be the outliers because you can see that data set jump from 36 to 40 to 60, right? So that is the big value. That is the big jump. And then from 60 to 120, that's doubling the value. So I guarantee you 120 would be the outlier for sure. But 4 is safe. I guarantee you 4 is safe because we can look at the difference between 4 and then the Q1, the difference only 13. But the difference between 40 and 120, that was 80. Even though they occupy the same 25 percentile, but they occupy different data set value range, right? So it's going to be a big difference, okay? So that's pretty much for the examples here. And then we're gonna do one more example before we move up to chapter 6, okay? Again, I'm going to skip the step-by-step theorems and the empirical rules and also the z-score because we're going to learn all of this in the later chapters, and it's generally not hard to figure out what it is. I just do one example, question number 2, and then we're going to move up to chapter 6 if we have time. Okay, so let's take a look at the question number 2 right there. And let's see. It shouldn't be that hard. Let me just do it if we have enough space here. But no. All right. Can we have one more? Yes, so we can have like 5. So for instance, I can make that example, right? So 40, the next will be 60, and then 120. I can make like 140. It might change my Q3, but still the Q3 jumping from 40 to 60 is not going to be a big jump. And if I go to like 140s here, and you might have another outliers with 120. Okay, so it just depends on how many data that's going off the tangent before we can figure out the the Q1 and Q3 respectively. Okay, so yes, we can have more than one outliers on example. So this is the census reports, but this question was done more than 10 years ago, and it might not correctly be reflected to what we have right now. So we measure the amount of time that people spend on their commute to work. So remember, the travel times can be different from 7 minutes up to certain things. Okay, so we going to have the lower quartiles. The lower quartiles also called the Q1. So the Q1 is 7. It's also be called the first quartile. So the medians that we have for that example is Q2, and that is 18. And then we're going to have the upper quartiles. And this is Q3. And that's going to be representing 31 minutes. Okay, so let me just change the different markers so you can see them and view them a lot easier. Okay, and now we're going to have the mean equal to 22.4. So what do you think? So the mean will be called the average. So is the travel time distribution more likely to be approximately symmetric, positively skewed or negatively skewed? Okay, so we basically understand the fact that the medians equal to 18 is bigger than the mean, equal to 24, 22.4. So what does that mean? If the medians is greater than the mean, so the data set, there'll be more data going toward to the left. So it will be more small values compared to the big values. So in this case, it will be positively skewed. Okay. Basically, it's skewed to the right. In other words, so it can't relate to that pictures, the first one. Okay, so the mean is smaller than the mean, so we have this. Okay, small. All right, and now, what do you think? The minimum time, so the mean is 1 minute, and then the max is 205. And then I want to know if there is any outliers. So I think I forgot to copy the next one, the last part of it. So let me just double check the pictures. Yeah, I forgot to copy part C. So my question is, there any outliers and how can you tell? So we can actually construct the IQR, right? Will be equal to Q3 minus Q1. So we can't just say exactly like 205 minutes going to be the outliers, because I feel it's going off the tangents. Nobody actually spent more than 3 hours to work, including my sister. She actually here, she lives in New York, but she had to work in New Jersey. For some reason, that took her almost like 2 hours for that commute, but it's still a very long time. I don't think that many of us actually spend around 200 minutes to work, and that's going to be crazy. Now, when I compute the IQR, I'm going to take the Q3 equal to 31 and minus 7. I got 24. Okay. After that, I'm going to set up the lower fence. The lower fence going to be, it doesn't matter because 1 minute is good. One can never be the outlier. So we can take Q1 minus 1.5 times the IQR. Okay. And so the Q1 that we have is 7 minus 1.5 times 24, right? So the answers for that is negative 29. Are we good? So there's nobody actually spent negative 29 minutes travel to work. That makes no sense. Okay, so for the next part that we need to compute the upper fence. So the upper fence in this case can be determined by the Q3 plus 1.5 times the IQR. So for that example, so we're going to do like, so Q3 that we have is 31 plus 1.5 times 24. Okay. So in this case, we're going to have this is equal to, anyone help, please? 67, I believe. So the fence, yeah, I think I got it. So this one, 36 plus 31 is 67. So if the person spent 205 minutes, and that person's have to be the outliers, right? 205 is the outliers. That's it. Okay. Any concern for that? Any questions? All right. And
can you go back really quick to that page that you had just now?
Yeah. Thanks. So the maximum is the outlier, but the minimum is safe because the minimum is still bigger than negative 29. So we're good to go. However, the maximum was not safe because it's very unusual for a person who spent 3 hours for a commute. But it's also, I think it's also very unusual for people who spend 1 minute, except that we work from home. We just turn on the laptop and get on Zoom and start working immediately. I think that makes sense that the minimum travel time is 1 minute. Okay, that's still count in the analysis. But if people spend like 3 hours, more than 3 hours and a half, come on, you have to change your job for some reason. Actually, no. And in fact, on the exams, I might just ask you to do the final summary. Remember, if the questions only ask us to do the final summary, do we have to set up the low offense or IQR or something like that? No, right? So if the questions only ask us to do the final summary, we just stop right there, and that's it. So that's going to be the final answers. It should be taking around maybe 5 to 10 minutes to finish this question, unless the question asks us to do the final summary, and after that, can you identify the outliers? Then we have to do the IQR to pick up 50% middle chunk from Q3 minus Q1. And then we set up the lower fence and then the upper fence. And then after that, we need to see if there's any data set that's going out of the boundary. And that will be called the outliers. Other than that, we just stop at the final summary. Okay. Are we good?
I have a question. Why did we add 1.5 instead of subtracting it?
I'm sorry.
For the upper fence, why did we add 1.5?
Oh, why do we add 1.5? Yes, because we want to make sure that the range is good enough. So we need to add. So if we subtract them, it's basically going around. So we have to make sure that the fan is good enough. The fan is long enough. So we need to add. So we start from Q3, you have to add 1.5, and so that we can set the upper fence long enough to cover the good data set, to cover the boundary. Okay. In this case, we do the same thing from Q1. So we need to set up the lower fence. So it should be going to the left. So we have to subtract 1.5 times the IQR. Make sense a little bit?
I feel like you put the wrong sign, right? Where it says upper fence, I mean.
I'm sorry?
Where it says upper fence, it should be positive, right? Add 1.5.
Yes. So when we set up the lower fence, so we need to subtract 1.5 times IQR. But when we set up the upper fence, it should be add the 1.5. Yeah. So I'm so sorry. I just actually have a little mistakes right there. I apologize for that. Okay. So that should be at 1.5 times IQR to make the length longer to set up the boundary for the fence. Yeah, I'm so sorry about this. Okay. Any concern, any questions? Any question for that? Hold on a second. I also have the classwork for you guys to work on. So what is the aim for the classwork? The classwork is going to worth 1 point. Okay, 1 or 2 points. I consider that. Yes, atropedic. How do you know that? Maybe you have some communication somewhere around. So multiple choice. No, actually, no. Let me just make sure that we're gonna finish it by tonight. So we still have 15 minutes left, right? So I let you until like 9 p.m. to finish it. Don't tell me you don't have enough time for those questions. So what is that done? Oh, come on, Scott King. All right. And the classwork is going to, I just want to make sure that we know how to submit work on Blackboard. The classwork one was something that will be asked to do the mean and the standard deviation. Okay, for the second part that we need to figure out the final summary and identify the outliers. So I can tell you exactly. So 1 is not the outliers. It might not be, but 65 will be the outliers. I can tell you. Maybe 1 will be the outlier. I'm not sure because it's changing drastically from 1. The next value is 21 or 20. Yeah. Okay. Yes. Question.
Can I cut? So we have to submit this by 9 o'clock.
Yeah, you don't
Can I
have
get
to.
more time because I'm at the college right now and I have to go back home after this.
Oh, I see. So that makes sense. Oh, come on. It's like educated part. You don't get hurt if you don't do it, but you gotta be kidding. 11 p.m. So how is that possible? I'm gonna take me 2 questions and go up to 11 p.m. You can't just work on your pad, right? So work on a pad and submit it. It's a piece of cake. So okay, I can make it 10. Oh, come on. 9 was a little too lazy. Are you going to get yourself a break? Or get yourself a couple of drinks before start working on it? You gotta be kidding me. But okay, so because this is the educated part, so I can make this until 11. Okay, so that's gonna be the latest time you can submit work. I feel like 11 p.m. is the latest time. You can't tell. Okay, it took me like 3 hours and a half to go to school, change the school. All right. I feel like yes, until 11 p.m. Okay, so you cannot tell me like I have to work until 11. Just start from now. You can write them. I feel like writing that was easier. How can you type? Come on, type takes longer. I'm not sure how fast you can type. Maybe your finger moves faster than you write, if that makes sense. All right. You don't get hurt if you don't do it. Yeah, it's due in 3 hours. So if you cannot do these 2 questions in 3 hours, you're gonna get stuck in a class forever. How will we submit? Um, uh, how will we submit? You're going to click on the assessment, right? And then you're gonna click on the header. Okay, so just the title, classwork 1. And then after that, so we're going to just do it on the pad, or maybe you do it on the loose leaf. You take a picture for it and save it on your phone, right? Or maybe you can email yourself, or you can just submit it directly from your phones, and then you browse my computer, and then after that, you choose the file that you have on your phones, or maybe that's you have on your computer, and then you're gonna hit the submit button. Okay, so you don't get hurt if you don't do it, but it will be counted as your attendance as well. And also the educated part. It's just 1 or 2 points, not going to be worth a lot. But since we have a lot of classwork, you might have some points like if you do well on the exam, let's say I got 92 on the exam, so I have 2 points from the classwork. So I add 2 at the end of semester, you get 94. So for instance, that you get 99 on the exam, and then I have 4 points from the classwork. So I have to add 4, and will be 103. And I'm going to keep those points to the next exams and the final exam. But remember, your exam should not get more than 100 at the end, because last month, I mean, like a few semesters ago, I have some situation where the student get more than 100, and then the people are going to question me, how is that possible? The average was 100.5. That makes no sense anyway. Anyhow, no, you can't type if you want to. Do we need to scan? Not necessarily, just 1 page. If you want to scan, go for it. That will be lovely and easy for me to grade. But if you don't want to scan it, you can just submit directly on Blackboard. Can we type enough tests? Please don't. You don't have enough time to type, trust me. Just write them down on paper, and that should be a lot better, okay? Because the exam is, I'm not going to be here during the exams. It's more like the open book exam. So how can I know if people are not open book or open the book? Okay, if you can turn on the camera and do something else suspiciously. But anyhow, so just more like the open book exams, and you can just use whatever you want to. Okay, so anyhow, I hope you guys going to have a great night. If for those of you, let me just scroll up a little bit before we go, and if you guys have any questions to ask, let me know. Anyone, any questions? Okay, so I was like asking you people to learn how to submit it. So before you go, you can double check if you see the assessment on your Blackboard. Okay, assessments, not assignment. It's classwork number 1. All right, so I will see you guys on Wednesday. Take care. Yes, this is educated, 100% educated.